Hello, and welcome to the Introverted Manager. Today's video will be deeply personal. I would like to tell you about the project that I made recently called Days Lived versus Remaining. If you're uncomfortable with personal stuff and emotions, I urge you to skip to the Power BI part. Otherwise, let's dive right in. If you are still here with me, first I would like to tell you a story how this project came to be and why it's so deeply personal. So I had this idea for a long time, and it was stored in my notes somewhere along with other ideas that I had across years. Years, yes. But I never had time to actually execute it. And the idea was I wanted to visualize the grid. I wanted to extract the data about life expectancy in different countries and visualize it into a grid. The days that are already behind you and the days that are ahead of you based on the life expectancy. That was the idea. What I didn't realize how personal it would be. But I was in Thailand, I had some free time, and so I decided to actually finally started working on it. I was sitting in a cafe and I made first prototype. I added my data, my age, my sex, and my country of birth or country of origin, and clicked apply slicers. And to be honest, I started crying right there in the cafe, completely surprising myself. I started crying because what I saw on the screen was something that triggered a lot of thinking. I saw that half of my life is already behind me. Half of my life is already behind me, and for the last 15 years, I was more often unhappy than I was happy. And so I thought to myself, how I would like to spend the next 15 years. And you can see I'm getting emotional here, and that's why this video is deeply personal. How I would like to spend next 15 years. That's what my tears was about. I was thinking that if half of my life is ahead of me, out of those 30 plus years, and currently I'm 34, and the grid showed me that I have around 35 years ahead of me, there will be way less active years when I am still healthy and can do anything. How do I want to spend those active years? Do I want to spend the next 15 years being more unhappy than happy? And that's how this channel, the Introverted Manager, came to be. That's another idea of mine that was in the storage for a few years, which I never had time to execute, which I am doing right now, here, with you. Let's review the report. Okay, so this is days lived versus remaining. This is the grid that I was talking about. The uniqueness of this report is that this visual is made using Deneb. It's not standard visual that Power BI provides, but rather a custom one made with declarative language using Deneb functionality. And I will dive deeper into that at a later point. Let me start with showing you the data model itself so you understand how the data is structured. So I will go into transform data. And let's give it a second to load. For this report, I'm using multiple APIs. One of them is from World Health Organization, which provides data about life expectancies in different countries. Every 4 or 5 years, they do research and collect statistics on life expectancy, and they provide this information for free on their website via API and also via other sources. But I like working directly with API, so I don't have any hassle with files. So therefore, I'm using their API to get data about life expectancy across the world. This is the original data, unstructured, or actually this data is pretty clean already. What I needed to do is just remove all the parts that I don't need and structure it in a way that will be more convenient for me. So this is the start state and this is the end state. Let's briefly go through the transformations that I made. So I removed all of the columns that I don't actually need. And bear with Power BI, there is quite a lot of data, so it's a bit slow in that regard. So there are multiple time dimensions. As I said, actually every 4 or 5, sometimes 10 years, they do research and collect data about life expectancy. By default, in this API, they provide data for 2000, 2010, 2015, and 2019. I don't actually need all of the data because I'm mostly interested in the most recent one. Therefore, I actually filter it out, and you can see it here. First, I find maximum. Let's give it some time to process. So first I find the latest available year in the API. So currently 2019, maybe this year or next year, they will update the data. So the M code will always take the latest data available on the API. So 2019, and then I filter using this year. Okay. What else do I do here? By default, this API provides data for 3 sexes: male, female, and both, averaged for both. I wasn't planning to use the both option, therefore I just left male and female. Although, thinking about that later, I think I should have left one more option for people that don't want to specify their sex. Anyways, not the topic of this video. There is life expectancy data, which is in years with some decimal points. And what I do, I also add custom column, total life days, which basically multiplies life expectancy with average days in a year. Average actually is 365.25, right? Remember those Februaries when we have 29 days to account for those. And I'm left with this simple table: country name, region name, although I'm not using it, sex, life expectancy, total life days. One thing that I do here as well is I actually merge or join another table. Another table is countries, because by default, let's see, this data only has region and country code. So I needed to add some data about with country name. That's what I do. This is another API request where I get country names and then join to the original table that I will be using. Another API that I use here, or actually two, is country flags. It's a free API that provides links to pictures of the flags I wanted to display them in the report, in the slicer. So I found free API, which again only provides, let's see, the source. Rename columns, It provides country names and country codes. But the thing is, since it's two different data sets from different sources, World Health Organization and some other source, countries can be named differently. And for example, in case of World Health Organization data source, they have 3 letters country codes. This API has 2 letters data codes. So again, I needed a way to join those 2 data sets. Therefore, I brought in another one which has ISO 2-letter codes and ISO 3-letter codes. And by using this, first I joined this into country flags to get country names and to get ISO 3 codes. And then I joined this table with World Health Organization dataset. So there are multiple dependencies and multiple layers. That's what goes into preparing data set for later visualizing data in the reports. You will have to go through that while working on yours. It always takes, specifically when you bring data from multiple data sets, you always have to jump through those hoops to actually make data work together and combine it together. Anyways, I'm going into the weeds here, so let's move on. And icons, I will not be focusing on that much. Here there are a few icons that I wanted to store in base64 format, specifically inside the model, not queried from somewhere outside, from some API or from some website. In case it goes down, I wanted to store it internally. Again, not the topic of this video, therefore I will move on. So this is the model. Let's move on to relationships. So I will close this. I will close this. Come on, okay. When it comes to relationships, there is actually just one between countries and life expectancy at birth. Reason for this is that I wanted a slicer or needed a slicer where you select your country. And again, here, as you can see, there is one-to-many relationship. But what's different about this one is that it's the cross-filtering is set to both. It's not standard, and you should be really careful with this, with setting to both. It means that if I select something in life expectancy at birth, it will also filter data or cascade into countries table. And the other way, if I select something in countries, it will cascade and filter data in life expectancy at birth table. This will be usable later on. And there are 2 more tables. One is icons that I mentioned already. We're not focusing on that right now. And your age, which is a custom parameter or quite simple. Generate series table from 1 to 125 to use for slicer, where person selects their age. And later on, I use it in calculations. Okay. So this is the model. Let's move on to the report itself. And actually, let me show you how it's supposed to look like by default. By default, that's what means let me try to remove 0. Actually, clear all selections. Okay, so as you can see, the default value is for your age measure is 30. That's why it always shows up with some value even when I reset all of the slicers. Okay, by default, this is what user is met with. They met with empty grid. They actually don't see the grid until they select their parameters. This is done by design. Reason being is that when there is no filter context, Power BI will actually load all of the available data. In case of the custom visual that I read, it would result in a crash. It will eat up so much memory trying to process all of those hundreds and hundreds and hundreds of rows of data, actually thousands and thousands and thousands, hundreds of thousands of rows of data, that it will eat up all of the memory Power BI provides, and at some point crash when there is no memory left. That's the reason why I introduced multiple checks and guardrails not to load anything into filter context until user selects specific slicers. Okay, we'll come back to that a bit later again. Now let's try selecting the data and we'll see how it works. So I will actually select my parameters so you see what I saw in that cafe I talked about early on. Male, and I'm from Belarus. And let's apply selections. Again, I turned on a button to apply selection so it doesn't apply automatically when the user clicks around. This is by design, specifically to minimize the back and forth of data. And now, once I selected and applied selections, you can see the grid. You can see that I have around half of my life left ahead of me. Although, let's not focus on that right now. So there are two custom visuals. One is up top, which is a simple line, which shows from baby to the death, and shows this icon which moves together with the grid, with the days past or days remaining. This is part of the custom visual too. And second custom visual is this grid of squares which colors days that lived and days that remain in different colors. This is based on the data from life expectancy data set. Therefore, if I, let's say, select different age, wrong. 8 updates. If I select different country, Barbados? Not sure. The grid updates as well. The count of squares is dependent on the source data. Okay, so let's briefly look into how I check that there is something in filter context. There is actually multiple measures doing that. For the sake of safety, I do it in every measure. Although it was possible to do it just once, you will see that I have multiple layers and safety checks. Maybe it's my QA background, I don't know, but I'm doing multiple safety checks before I actually load data, and even after I load data into the visual, I still check the data there to make sure it's within bounds. All not to crash the application. So here you can see that there is if statement and has one value operator, which you probably understand already. It checks that there is only one value selected for sex or country name. And I'm going back to what I said before, is that when you slicers work this way in Power BI, that when you unselect the slicer, when there is no selection, it actually loads all of the data into filter context. Therefore, means if there is no female or male selection, there will be two values in filter context. Or when there is no country selected, there will be list of all the countries in the filter context. That's what I'm checking for here, that there is only one value. If there is one value, it means that user already made a selection and we can proceed further. And we can calculate. Otherwise, we just return 0. We return 0, so that's the only data that Visual receives. And basically, I'm doing the same in all of the visuals. All of them have condition that there is only one value selected. Okay. Let's actually move on to, let's briefly look into this one. There is one custom solution that I want to highlight. Once again, it's a Deneb visuals, which I believe you should install from App Source Store of Power BI Visuals by default. I don't think it's available. Once you do, you can actually use, let me press edit here. You are able to use declarative language to describe your visual. And I will link website with a lot of examples for those custom visuals. There are some really nice ones, really good ones that Power BI doesn't provide by default. But for this, of course, you need to learn the syntax. There are two, let's say, sub-syntaxes, Vega Lite and Vega. Vega is more complex ones and therefore can do more complex visuals, and Vega Lite is a bit easier one, but there are some limitations to what it can do. So for the top visual, I use Vega Lite, and the only thing that I would like to highlight here is that, as you can see here, this icon of a person walking is actually image stored in base64 right within visual, which it decodes and displays. I wanted it to work, or I wanted visual to look this way, specifically this way, and that was the way to do it. It might not be the best thing to do performance-wise to store assets within the visual itself, but in my case, because I wanted to do it in a very specific way, it was the only way, or at least the only way that I know of. And that's basically everything that I wanted to highlight about this one. Let's move on to the second one, to the grid. Let's give it a second to load properly. Okay, so as you can see here, I'm actually using Vega, which is more complex version of that declarative language. Now that I'm learning Swift, it's actually quite similar to Swift, to be honest, the syntax itself. Although, of course, they're tailored for different cases. So this is your specification here, where you describe how you want your visual to look like. There's config, basically line heights, colors, font sizes, fonts, etc. I didn't change it much and use default version, to be honest, because my visual is not about that and it doesn't actually have any text, with one exception which I will highlight later. Settings, the only thing that I changed here is switch to Vega. And what else? Yes, once you add your data fields here, as you can see, I've added 2 fields here. Specifically, those conditional fields or conditional measures that do not provide data unless there is only one selection. Again, by design, so it doesn't pass too much data into visual and the visual would crash. So I use those conditional measures here as data sources. And then here you have to map what is in your code with those fields that you provide, with those value fields that you provide on the side of Power BI. So you have to do that mapping too for it to work correctly. And you can see the data that visual works with. This is the data that is generated as part of the visual. We'll walk through what it does. Signals are, let's put it like that, the external parameters that might affect the visual. For example, the size of the visual on the side of Power BI. You can use that size and make visual adapt to different sizes, which I do in my code. And logs, this will be useful once you start working with your visual. You will see all of the issues that come up. And let me tell you, it took me a few days to iron out all of the issues that I had. Oh, let me go back to the code and let's do a walkthrough. Okay, so the signals, let's first start with signals. As I mentioned, those are external factors that Deneb or Vega code has to take into account. What I'm doing this is I actually receive the size of the visual itself, and I am trying to figure out the sizes for my squares. How many squares, the sizes for the squares, depending on the resolution available to the visual. The reason for this, there are 2 different cases and specific case for mobile version. I also did mobile version, which I didn't show you, but I can do that now. Let me switch to mobile version. Let's give it a second. Okay, as you can see, there is working mobile version, and specifically this visual, custom visual works as well, even in mobile version. To do this, I needed to provide certain breakpoints that will account for mobile version and adapt visual for mobile version. That's what is it about. Let's go back to the specification. Let's give it some time. And mind you, I'm working in virtual machine because I'm working on Mac, therefore Power BI by default slower in this case. So that's why everything takes certain time and patience. Okay, so container size is actually a container for the visual, and then I dynamically calculate the size of the squares based on resolution available. What else? Similarly, the size, like columns and row size, is calculated dynamically based on the size of the visual. What I wanted to highlight here is on the side of the visual, I validate that data is within bounds too. This is another layer that I've added just in case. If data is out of bounds, instead of trying to build a grid, I actually do not display it and instead display text message to the user. Let me scroll down here. If the data is invalid, meaning if it's either age is less than 0 or, for example, older than 125, it will provide this message to the user. Selected values are outside of the safe range. Please make your selections in the provided slicers. And actually, that shouldn't happen at all or ever, because I already do checks in DAX measures before loading data into the visual, but I still wanted to just add another layer. What else can I highlight there? The rest is basically describes how your visual should behave or how it's built. And another thing that I wanted to mention here is that to actually visualize the grid, I needed to provide Vega with array of values. But the thing is, what I'm passing into the visual is just two values: the days that are lived and the total life days. Therefore, what I'm doing here is I'm creating a array sequence from 0 to total life days, and the same with days lived. So two arrays that are used to color. So first visualize the squares and then color those squares based on conditions. And that's days lived versus remaining. For those of you interested, you can actually find interactive version on my website. I will link it in the description. And for those who would like to get source file and explore visual code, I will post it on Patreon, which will be linked in the description as well. That's all for today, and see you in the next one.